Okay, this is chapter 12 of the book, How to Prevent Dementia, and we're now going to go through a major concept called excitotoxicity. This is super important, one of the most important things you could possibly know about the brain and protecting the brain from injury and becoming demented. We're also going to talk a little bit about how the concept of an energy crisis in the brain, of psychiatry, and what a disaster psychiatric medications are for the brain. And then we're going to get into my theory of dementia, basically neurovascular uncoupling. So this is chapter 12. Now we'll go to the page. Okay, we'll start out with this drawing here of the plasma membrane. And the main thing to get from this is that, all animals on Earth eat more potassium than sodium, and humans used to be that way by far. We used to eat about 25 times as much potassium as sodium. Nowadays, we're eating like 10 to 1 sodium to potassium with these processed food diets like the standard American diet. And that's a problem because you need these plasma membrane gradients of sodium in order to do the physical work of a cell. Having a high concentration of sodium outside the cell, about 10 times what's inside the cell, enables you to run all these other pump systems. And in a sense, the human cell runs on an electrical system, okay? And eating the proper diet of the plant-based foods with lots more potassium than sodium just naturally makes it easy to run these gradients. Typical neuron has a plasma membrane gradient about -65, -70 millivolts. Okay, so that's the electrical component of it. The chemical component of it is the difference in the concentration of the ions across that membrane. And about 2/3 of the energy of a neuron goes to running that gradient. So you can tell it's super important. If it wasn't that important, the body wouldn't use so much energy to do it. Okay, anyway, so why are plants the species-specific diet for humans? Because they got lots of fibers. That protects you from leaky gut. That protects you from leaky blood-brain barrier. You got more potassium. Those are the vasodilators. More magnesium, also vasodilators. More nitrates. We talked about these as precursors for nitric oxide. Vasodilators. Staying alive and healthy is largely about keeping your arteries open. And vasodilation is part of keeping your arteries open. Okay. Also, more antioxidants to prevent oxidative stress. Okay, so what kills people? Their arteries get plugged up, and they have an excessive oxidative stress, okay? So plants do everything to prevent that. They have the antioxidants and they keep your arteries open and they're low in fat. The good plants are low in fat. And they're also more alkaline. Where does cancer grow? Hypoxic environment with the arteries plugged up, high oxidative stress, and acidic environment. So plants are the opposite. Low-fat plants are the opposite. That's what you want. Believe me, when I started out studying medicine, the last thing in the world I would have ever thought was the key to health was a vegan diet, okay? All right, when I grew up, I was a college wrestler, tough guy. My heroes on the movies were, guys like Charlton Heston and Rocky, Sylvester Stallone. Wrestlers wanted to be tough guy. And I used to think of, a vegetarian as some wimpy, hippie, sandal-wearing, tie-dye, Grateful Dead shirt, scumbag, drug addict, get out of here, I would have been the last thing that I thought. Believe me, I was kind of shocked once this all came into my awareness. But it's right, and that's why I stick with it. Okay, we're going to talk about how a cell works here. And this is something really worth knowing. This is just fundamental to how neurons work. All right, so here you've got 10 times as much sodium. Na is for natrium, for sodium like in Latin, and then 14 inside, so it's 10 times higher concentration outside the cell. And ions want to equalize their concentration, so they're going to want to come into the cell for that reason. Also, sodium has a positive charge on it. You've got a negative charge inside the cell, so sodium wants to come in for that reason, a charged region or an electrical reason. So you have an electrical gradient and a chemical gradient by the difference in concentrations. And the pump over here, potassium, sodium, ATPase, so the pump is driven by ATP. You need magnesium to kind of hold the third phosphate on there so it doesn't pop off because the phosphates have strong negative charges that repel each other, but magnesium's positive charge holds those phosphates together. So you need magnesium to run all these ATP pumps. And 2/3 of the energy of a typical neuron, half to 2/3, is used to maintain this pump, to maintain these gradients, okay? So that's how a cell functions. That's what keeps it alive. And so that's why you want to eat the proper amounts of potassium and sodium. Otherwise, you mess up these gradients and you just create a lot of extra work for the cells and make them less efficient. Okay, then the other thing to be aware of is that calcium is far, far, far higher, over like 10,000 times, even 15,000 times higher concentration outside the cell than inside the cell. So what that means is calcium really wants to get into that cell. It also means that once the calcium's in the cell cytoplasm, it's hard to get it out because it's totally, working towards equalizing its gradient. So it takes a lot of energy to pump calcium out of the cell. I'll also show you it can be pumped into the endoplasmic reticulum. We'll show that on the upcoming slide. And calcium is what turns the neuron on. It's the light switch to flip it on and then enable it to do whatever it's supposed to do. So a typical neuron releases a neurotransmitter. That would be its job. In a skeletal muscle, when calcium comes up, that would get it to contract, to vasoconstrict, okay, raise blood pressure. Okay, and then it relates to lots of other things that cells do. So that's all key to know. And this is why I'm a big believer and emphasizer. You don't want to be adding extra salt to food. Just a little bit on the outer surface, like McDougall says, fine to get the person to eat it, that's fine. But if you're wanting the best possible performance you can get out of yourself, you want to try to optimize everything. Okay, that other thing was called the NACA exchanger. NCX is the abbreviation for NACA exchanger. And so Na is for sodium, Ka is for calcium, and exchanger means it runs on secondary active transport, meaning it uses the gradient established by the sodium-potassium ATPase pump. Okay, we're going to talk about the PMCA, plasma membrane, calcium ATPase. We'll talk about that a little later. That's another ATP-dependent pump that pumps calcium out of the cytoplasm. This is just showing you the relative concentrations. We saw that with sodium, it's about 10 to 1, and it's about the same thing for potassium, about 10 to 1, except it's the opposite direction. There's 10 times as much potassium inside the cell as there is in the extracellular matrix. And then we talked about calcium too, also much higher outside the cell. All right, kalium is the Latin for potassium. That's why you'll see that. Okay, here's just a basic neuron. You've got the cell body, as defined by where the nucleus is in the DNA. These are the incoming sensory information to this neuron, the dendrites. They receive messages. Once this neuron is activated and decides it's going to fire an action potential, the action potential is initiated over here at the axon hillock, at the beginning of the axon. This is myelin. These are fat coatings like the insulation of a wire, and they enable the neuron to conduct more rapidly. The action potential can jump from one side of the myelin to the next side, to the next side, to the next side. These are called nodes of Ranvier, these intervening parts of the neuron. This whole thing from the cell body to the synaptic terminal or axon terminal, these are called, this is called the axon. So anyways, the action potential of electrical depolarization is conducted down the neuron, and then once it gets to the synaptic terminal here, it'll, if you get enough calcium coming in here, it'll activate it and it'll release a neurotransmitter across the cleft. And that'll then activate the postsynaptic neuron. Okay, so here's a picture of that. Another important thing to get out of this picture is notice that the action potential, which runs on sodium, it will then activate a voltage-gated calcium channel at the level of the synaptic terminal, and it's this calcium coming into the cytoplasm that causes the neurotransmitter release. So once again, calcium is the major on-off switch. Sodium and potassium are like minimum wage workers that just prepare everything so calcium, the aristocrat, can come in and make things happen, so to speak. Okay. Now here's a typical neuron in the brain, and this will be, let's say, a serotonin synapse. So under normal serotonin synapse, the voltage-gated calcium channel would be opened up. The calcium will signal for the neurotransmitter to be released. Neurotransmitter vesicle merges with the plasma membrane. Its neurotransmitter then diffuses across the synaptic cleft. It'll bind to the receptor on the postsynaptic membrane. Here it's a serotonin receptor, and it'll exert an effect on this postsynaptic neuron. Then the serotonin in the synaptic cleft will be removed by a reuptake transport protein, and it's called serotonin reuptake transporter, and then it'll be packaged back into vesicles. All right, so the point I'm saying is if you give a drug like an SSRI, serotonin selective reuptake inhibitor, so it inhibits reuptake, that'll cause more prolonged and increased amount of serotonin in the synaptic cleft. But the problem is over time, in the words of Bregan, the great psychiatrist, greatest psychiatrist who ever lived, what he'll say is the neurons will fight the drug. The brain fights the drug. So they might make fewer synaptic vesicles containing the serotonin. They might put more reuptake transporters on this presynaptic membrane for reuptake of it. They might make fewer, instead of all these receptors right here, they'll make fewer receptors on the postsynaptic membrane to dull the effect of this increasing the concentration of the serotonin in the cleft. So the point is, it's difficult to make any progress with these psychiatric drugs because the brain fights the drug and you end up with something rather different than what you started out with, and you might have a hard time getting back to this original configuration, which is what you probably want to do. So overall, and I even put the word medication in quotes because I wouldn't even really call a lot of these things medication. I think they're toxins. Okay, you know, and again, it's a billion-dollar business, but psychiatry is like one of the most overrated fields in all of medicine. And here's another example of why that is true. Because a neuron is typically not just these, you know, the pre and the postsynaptic neuron as we always learn. That's a good way to conceptualize it. But in real life, a lot of times there's other neurons in the vicinity which can exert an influence on it. And it's more like this symphony. And so it's not that easy to just use one drug to change this. You're going to get all these compensatory changes, and it's hard to generate any type of positive effect in the long run. And Bregan says this, and my knowledge of psychiatry would agree with it, that basically psychiatry is like different types of lobotomies. You know, you come in, you take these pills, and they progressively cause more and more brain damage. That most psychiatric drugs have the effect of a slowly progressive chemical lobotomy. Okay, and then if the drugs don't work, a lot of times they'll recommend the patient, let's say a severely depressed patient, for electroconvulsive therapy, ECT, and that's a form of an electrical lobotomy. I mean, it's rather insane, running electric currents through somebody's brain. What a psychiatrist will tell you is they've got people with refractory, suicidal, depression, and that electroshock seems to help. Yeah, and make them forget what they're depressed about by causing brain damage. And there's even now papers about doing surgical lobotomies, you know, putting wires and tubes in the brain and destroying parts of the brain. I think it's rather crazy. Why not find God and a purpose in your life? Now, don't get me wrong. There are some serious cases and there are some acute psychotic episodes that require medication to control the patient. There are special circumstances. I get that. There are times when people benefit from short-time use of psychiatric drugs. But in general, the most common thing is you got all these outpatients taking pills every day for the rest of their life, and most of that is misguided, and they all end up causing brain damage. Okay, so this is Peter Bregan's word, the greatest psychiatrist who ever lived, Harvard-trained psychiatrist. He said, most psychiatric medications, basically, he actually says all psychiatric medicines cause brain damage and are essentially a chemical lobotomy. And believe me, I don't come easy to saying this. My father was a psychiatrist. When I was growing up, I very much admired my father. He was my number one role model. My dad was, you know, he had been boxing champion of the United Kingdom. He was a tough guy. He was a real hard-working guy, a good role model, worked all day as a clinical physician. He was like a chief of 2 departments. He also, every night he would read. And so I got in the hand, you know, when I'm around my dad or my uncles will come by or his friends, they'd sit around and talk about books. And so I learned as a young guy, if you want to be respected in this community, you better read books and be ready to talk about them. And that was great for me because even though I didn't like school, and what kid is going to like school? Some lady, you don't know her, she's talking about a bunch of stuff you don't care about, and you got to sit in a chair for 8 hours. That is not a natural thing for a young boy to do. And I told you before, I got suspended from school, I got kicked out of school, I got put in, luckily there were no drugs, they would have drugged the crap out of me for attention deficit, and they put me in a pod classroom where I had to sit by myself for like 2 years, and there was no one to talk to. I'm by myself in this room, just a study hall by myself. And I think the reason is I was smart, and I would do the homework in 5 seconds, then I would joke with my friends, throw a paper airplane, and we'd laugh and giggle, and I was considered disruptive, and believe me, it was not a pleasant experience. What kind of saved me too was my mother. My mother told me, I won't give you a ride to wrestling practice anymore if you keep getting in trouble in school, because I had been suspended a bunch of times and put in, like I said, solitary confinement. Okay, so anyways, here's a book I want you to tell you about. This is a lady, and by the way, I think it's insane to give these amphetamine-like drugs to children. Like I said, if you were on a street corner and you sold an amphetamine to an adult, that would be illegal. But now you're going to give it to a kid for attention deficit? It's insane. It really is. And everybody just looks the other way. And I think also the men in our society have been so feminized we allow this craziness. You know, all these children poisoned with these drugs, and gosh, and all the other terrible things done to children in school. It's awful. I mean, they're going to look back on our age as just a complete disgrace. They say, what utter scumbags you people were to do this to children. Okay, but you can never change it because it always comes from above, and the big money supports the above, and the average proles and peasants are too stupid and lazy to ever speak up in their own self-rights. Okay, so anyways, I want to show you this book here. This is A Mind of Your Own. This is by Kelly Brogan, and she's a good lady. She's a psychiatrist, and I'll give her a lot of credit. She did speak up about how the whole neurotransmitter theory of depression, you know, serotonin was bogus. It's never been scientifically shown. It's just a big sales pitch to trick patients into taking drugs. And she spoke up about that a long time ago. She's a smart lady. She's like an MIT trained doctor, and I think she's half Irish and half Italian, so kind of hot-blooded. She's a little bit hyper and crazy, but she's nice. She's good. I read a couple of her books. Her books are good. I mean, don't get me wrong. She doesn't know nutrition as well as she should, but she's on the right track. She's working towards becoming a vegan, even though she's got a ways to go. And she used to know Nick Gonzalez, who was a very interesting guy as well, and a pretty famous doctor himself. And he is another guy who was a bright guy, and he was making a lot of progress. I don't think he fully got where he should have been on nutrition, but he was working towards it. So anyways, if you check out her books or her videos, I think you will like her. She's nice. She does her best to tell you the truth and say something useful. Okay, let's see. Who's the next one? Okay, this one is Bregan. Okay, and this is the best book if you want to, sorry about that. If you want to understand psychiatric drugs, sorry about that. Okay, here's the guy Bregan. I was trying to get it all onto one picture. I should have shrunk it more. Oh, it's reasonably shrunk. All right, so he's the guy to know about, Peter Bregan. He's the greatest psychiatrist who ever lived. He, became disillusioned with psychopharmaceuticals because he saw they were hurting the patients rather than helping them. And he's written multiple books, but this is his best book for understanding the drugs. So, Disabling Treatments in Psychiatry. Yeah, they all cause lobotomy. Drugs, electroshock, and the psychopharmaceutical complex. So he's got videos online that you could watch. You could read this book or any of his other books. They're all quite good. And he basically says what I'm saying, what any smart person is who studies it. You need to, in a sense, have biblical ethics and love the patient and put the patient's interest above everything else. And I guarantee you that is almost never done. Because you have to do that. And the reason why it's almost never done is there's no money in it. There's no money in educating the person and all this other stuff and actually doing what's right by them. The money comes from sell them drugs, sell them a procedure or a surgery, and ship them on their way. So anyways, like I said, you want to know Bregan. And he also wrote a book about how to withdraw from psychiatric drugs. And he did a lot of good things, that guy. He died not that long ago. Okay, this is a book here called Anatomy of an Epidemic. The author's name is Whitaker, and he spent a long time studying the effect of psychiatric drugs and saw all the problems. He's a journalist, but he's a very bright guy, and he did a real good job of studying the drugs and, for example, the complications of attention deficit. And his lectures, I made a lecture about him before. I think I made one about Bregan before. I had a whole series of lectures on Is Psychiatry a Joke? Part 1, Part 2, Part 3, Part 4. And there'll be lectures in there about Whitaker and about Bregan. I didn't do one about Kelly Brogan yet. I should do one about her. Okay, so what would I say? Like, how do I reconcile my father being a psychiatrist and all this stuff I learned about psychiatry that's not so good? And I think basically, the average doc, they mean well, but they sort of learn what they're trained to learn. And then they have a lot of respect for, like, the Ivy League famous places that write all these papers. And I can remember back in the 1980s, there was this irrational exuberance, to borrow a phrase, for psychiatric medicines. And when Prozac came out, everybody thought it was the greatest thing. It got so much fantastic hype, the neurotransmitter theory of depression. And just for perspective, like, my mom would play tennis at the tennis club. She was champion at the tennis club. And my dad would get all these free samples of Prozac. And so if my mom's friend was sad, she goes, "Oh, I'll get you some Prozac." Okay, and she would give it to her friend. Now, I know that's crazy, but that's what happened. And at the time, no one blinked an eye. Everybody thought that was a reasonable thing to do. To me, now it sounds insane because we know better that Prozac's a very dangerous drug. And there was even a paper I wrote about it in one of my previous his Psychiatry Joke lectures that they were recommending it be used for chemo. Luckily, my mom didn't have many free samples. Probably just had a brief, few days placebo effect, but that was kind of the attitude back then. Okay, this guy right here, James Davies, wrote a great book about how the DSM is basically a joke, Diagnostic and Statistical Manual of Psychiatric Diagnosis. It was just a bunch of psychiatrists beholden to the pharmaceutical company largely, writing down what they would consider a reasonable diagnosis and basically setting up a system to get people to prescribe more drugs, okay? It's like probably the least scientific field in all of medicine is psychiatry. There's no laboratory, objective diagnosis. Okay, then here's a guy who wrote a really good book, Thomas Schaas and the myth of mental illness. Okay, and somebody might ask me, why am I going through all this? Because I see patients getting, their lives destroyed by this all day, every day. I've seen lots of people in my direct personal experience have their lives destroyed by these psychiatric medications. So I think it's good to know about it. And they cause people to go crazy. They cause people to be violent. They cause all kinds of terrible things in people. All right. And then, a guy like this comes along, and this guy Schaas, Thomas Schaas, he was a brilliant guy, and he pointed out a lot of good things, okay? So I'll just share with you some of his quotes. And you also need to know these because if you don't know this stuff, you become a victim, all right? Most patients, they're kind of hopeless and stupid, and they have bad outcomes. Like people think, oh, America's medical system's good. No, it's not. It's a disgrace is what it is. And tons of patients have really bad outcomes. They walk in trusting the system, they get poisoned with these drugs that don't work, and they just go down the tubes, and they're kind of sad. They kind of have this lost look in their eyes, and I feel sorry for them, So not much I can do other than make these lectures and hopefully educate more people. Okay, Thomas Schaas. Mental hospitals are cemeteries for the living dead. The dormitory beds are the grave sites. Psychiatric diagnoses are the gravestones. The psychiatrist is the grave digger, and the patient is the corpse. Pretty sad and pathetic, but there's a lot of truth in that. And I remember when I was in med school, I knew a lot from my father, and I didn't know all this modern stuff, no. But I knew enough from my father and from all the patients, because my dad had an office in the house when I was a kid growing up. We weren't even allowed to answer the door when I was a kid growing up, because lots of families we knew sent their family members to our house to be seen by my father. He had a pretty good reputation. And what I'm trying to say is over the years, I started to see, wow, the scientific foundation for psychiatry, it's bogus. Okay, but growing up, I thought my dad was the big dog of great doctors. I didn't know any better. And he was a good guy, but he was relatively conformist like most doctors. He believed what he was told, and he was told the thing to do is prescribe these drugs. Okay, so here's another good quote by Thomas Schaas. In the animal kingdom, the rule is eat or be eaten. In the human kingdom, it is define or be defined. He who defines dominates. So this is what you'll see by whoever controls the rule-making system. And in the medical game, it is Big Pharma that controls the rule-making system. And it defines a hyperactive kid who's bored out of his mind as attention deficit. Therefore, that kid will be drugged. That kid can't say, well, gee, this class sucks and I'm bored out of my mind. That's why I keep staring out the window and fidgeting. He can't say that. Poor kid doesn't understand the big picture, isn't that articulate. The parents trust the school system, and so the poor little kid gets defined as deviant and bad and inferior, and they drug the shit out of him, and they give him a chemical lobotomy, and then the kid probably will have a hard time ever doing useful academic work the rest of his life. So it's wrong. It's sad, okay? So all I can do is tell the parents, trust yourself more than you trust the school. Don't let them drug your kid. Put your kid in another school is what I would do, okay? All right, more quotes by Thomas Schaas. Psychotherapy is the medicalization of human social problems through and through. 100%. And psychoanalysis is medicalization squared. Psychiatry is medicalization cubed. So what he's basically saying here is, people have problems, problems of living. Things happen, they make us sad, Our boyfriend or girlfriend, husband, wife leaves us, we're sad. We fail at something we cared about, we're sad. We get sad sometimes. That's just how it goes. There's disappointments. You don't get picked for something that you thought you deserve. And so you just have to, move on with your life. There's not much else you could do. Okay, Thomas Schaas. The less a person knows about the workings of the social institutions of society, the more he must trust those who wield power in it. And the more he trusts those who wield such power, the more vulnerable he makes himself to becoming their victim. Yeah, and I see a lot of patients, they walk into these modern hospitals, and in a sense, science, so-called science, has become the religion of the modern world. The modern world thinks that science is this good, real thing. And a lot of patients, they walk into these modern hospitals. I've seen tons of patients in my life saying, oh, this is so impressive. The CAT scan machine, the surgical suite. You know, I was an imaging guided surgeon before I became a neuroradiologist. And they're all impressed by everything. They think it's so wonderful. They don't understand. The system is made to make money. What happens to the patient is irrelevant. And everybody says they care about the patient, but very few actually do. Okay, because there's no reason to. And I know all this sounds weird, but it's important that you understand how a hospital works. Okay, because if you don't, you become a chump quite often. You get chumped into doing all kinds of things. And so the best way is to figure out how to stay healthy so you avoid the medical system. An intelligent person wants to avoid the medical system. Like people say, why don't you go for a routine checkup? No, that's the last thing in the world I would ever do. So they're going to find some normal variant and then send you for a workup, and then that's going to lead to finding something else, and then you're stuck in all these follow-ups. You know, you can be stuck in follow-ups for 5 years, and then you can't make a plan with your life because you don't know if you're sick or not. You know, the old joke is, what's the definition of a healthy person? Somebody who hasn't had a body CT, a CAT scan of the chest, abdomen, or pelvis. Because there's always a bunch of incidentals. There always is. We call them incidentalomas. There's some little nodule in the lung that you got when you had a cold when you were, you know, a kid. Or there's some scar, you know, from old trauma, all right? And you don't know. So you don't know if it's cancer, so you follow it for at least 2 years. You got a cyst on your kidney, a cyst on your liver, a nodule on your adrenal. It's all normal variations, but everybody's afraid it could be cancer. So you get followed for years, and it could cost you tons and tons of money. Put your whole life on hold for what? Okay. Smart move is be a low-fat, low-sodium vegan. So your risk of having a problem is so low that to get these scans is insane, because the likelihood of a false positive is up here, and a true positive is very low. Okay, so we're going to continue with Thomas Schaas because he's really fighting for the patient. And notice, whenever a doc stands on the outside and fights for the patient, they kind of almost get blackballed by the conventional medical system. Okay, and also ask yourself, you know, I'm one of the smartest doctors around. Why am I talking to you, the pros? Why am I not talking at all the universities? How come all the universities don't invite McDougall and me to talk? Because when you start teaching this nutrition, epidemiology, and toxicology, you kind of become a bit of an outcast from the medical system. For many years, no one would send McDougall a single patient. Zero. None. They would come, the doctors and their families, because they wanted to get the best possible care available from him. They knew he was right, but they would not send any patients to him. All right? And I can tell you, I don't ever get invited to the universities. How come, you know, I know tons of doctors. I get lots of compliments from them all the time. How come they don't ever invite me to go to the different universities and speak? Because they know this would not go over well with the big upper manager. They're going to say, what's all this nutrition diet bullshit? And we're going to lose tons of money if you start, you know, getting the patients talking to all this stuff. You know, you do open heart surgery, you can bill for $150,000 with all the follow-up care. You're going to teach somebody a diet for, you know, $1,000 or for nothing? Are you out of your mind? Are you insane? The hospital might go broke. We might not be able to keep all these fancy buildings. Okay, so that's what I'm trying to say is most modern science is just advertising paid for by these big corporations that make money off the system. It's not real science. Okay, an average person has no idea about the difference between real science and just advertising. Okay, all right, let's continue with Thomas Schaas. It's kind of like the purpose of my whole YouTube channel is to protect you from becoming a chump, because lots of people get chumped. The majority do. Okay, in the past, men created witches. Now they create mental patients. Psychiatry belongs in the same category as astrology, as pseudoscience. Saying a patient has a mental illness is similar to saying they are possessed by the devil. Okay, and then here, I kind of went past this one other quote here. Those who suffer from and complain of their own behavior are usually classified as neurotic, whereas those whose behavior makes others suffer and about whom others complain are usually classified as psychotic. Okay, here's a good quote by Thomas Schaas. Giving children medications for psychiatric diagnoses is not treatment. It is poisoning. Yes, thank you for speaking up for kids, okay? So here it is, a guy who speaks up for kids gets labeled a jerk because he's going to cut into profits, all right? And that's kind of sad, you know. Look at all the crazy stuff happening to kids today. And where are, there's some parents trying to protect them, but they kind of get shouted down, and it's pretty sad. And you'll find that if you go to other sites, there's a lot of talk about what's happening to children right now in schools. It's rather insane, okay? Castrating children in public schools. That's insane. It's so crazy. There's no other age where any of this stuff ever happened, and it's insane. Okay, Shaz continues. As the base rhetorician uses language to increase his own power, to produce converts to his own cause, and to create loyal followers of his own person, so the noble rhetorician uses language to wean men away from their inclination, to depend on authority, to encourage them to think and to speak clearly, and to teach them to be their own masters. And that's what you see right now with YouTube and the nutrition health experts, okay? I'm teaching you how to take care of yourself. I'm not asking you to buy some supplement from me. No, I'm just teaching you, all the things I've learned from being a doctor over 30 years and from seeing all the different medical problems all the patients have gone through, my friends and family have gone through. I've learned a lot over these years, okay? So somebody who's ennobling you and empowering you, that is good. Whereas somebody who's just telling you, well, the only way you'll ever be healthy is buy my supplement, okay? And that is, I think, BS, okay? And that's what I think also of the idea that you need omega-3s for your brain, or you need caffeine or other BS, or you need to eat more protein, you're going to be sarcopenic. BS, okay? That's what they say all about, that all the old people need to do, BS. The blue zone epidemiology tells you that's all BS. They weren't searching for all these things. Okay, Thomas Schaus continues. Self-respect is to the soul as oxygen is to the body. Deprive a person of oxygen and you kill his body. If you deprive him of self-respect, you kill his spirit. Yeah, and that just goes with, you got to believe you can do something before you're going to do it. So you have to help people and kids build up their confidence so they'll then become capable of doing more. And that's what someone does who loves you and who wants to help you. And I think my mother always did that for me, and I was very grateful to her. Okay, Thomas Schaus continues. As the internal combustion engine runs on gasoline, so the person runs on self-esteem. If he is full of it, he is good for the long run. If he is partly filled, he will soon need to be refueled. And if he is empty, he will come to a stop. Yeah, you got to believe you could do something before you even make the effort to try. And that's why you got to have that growth mindset popularized by Carol Dweck, the Stanford psychologist, because it's true. If you believe you can improve, you'll make the effort to improve. And if you believe your efforts will enable you to do something useful and worthwhile, then you'll make those efforts. And if you don't believe it, you won't do anything. Most people fail that I've seen academically and in a lot of other things is because they just don't believe they could really do it. They figure, well, I'm not that smart, so I'm not going to try doing these more difficult classes or other things, or I'm just not capable. But it's like all these students, and they just don't even know study skills or memorization techniques, and they have poor time management, okay, and they eat terrible diets. A lot of them could be dramatically improved. I would love to teach, college students, teach a study skills class in a college. And I also told you what a joke I think all these like Hispanic societies are. I wrote to tons of them, okay? Not a single one of these Hispanic societies ever wanted me to speak to their students, okay? A lot of them are a racket. They just want to get money and keep complaining about their problems. Have somebody come out, because I offered to do it for free. I've written a bunch of books on study skills, and I offered to speak for free at medical schools, at colleges, at high schools. Not a single any of these Hispanic societies. I was in a Hispanic society when my mother's from Puerto Rico. Not a single one would invite me. And I remember it back in my med school. They would invite some guy who, maybe took an extra year to graduate, was on academic probation all the way through. Bring him back. Oh, he's a good role model. Somebody like me who's got perfect board scores. No, don't bring him back. We don't want him. He has controversial ideas. Yeah, I'll teach him study skills and memorization techniques that I use. And that's what I see. I don't see a lot of unique, true desire to help persons lower on the scale. And the same thing with medical students. The first year of medical school, it's always taught by like the worst professors in the entire university system. They're basically out ready to be put to pasture. They don't know how to do, they can't do any useful research anymore. So they go, go teach the medical students. Because medical students have no money. They're already in the system. The university knows it's got them. They're not going anywhere. So it doesn't matter how bad their teaching is. Okay, Thomas Schaus continues. Traditionally, men have used power to gain sex, and women have used sex to gain power. Okay. Do you know what the difference is between an arranged marriage by the parents versus marrying for love? You can spend the rest of your life blaming your parents instead of yourself. Okay. anyways, I just thought of this joke because of that. All right, Thomas Shaz. People often say that this or that person has not yet found himself, but a self is not something one finds. It is something one creates. Okay. Thomas Shaz. Clear thinking requires courage rather than intelligence. Yeah, that's true. Because in order to think in a courageous way, you have to say the truth is the most important thing, or you have to say the patient is the most important thing. And most of the time, there's really no incentive to do that. So you'll notice a lot of times when you hear somebody speaking the truth in a courageous way, they're just saying what's common sense, and you already thought it in your own mind, but you were kind of like scared to go there. Because a lot of modern, so-called modern conceptual, contemporaneous thought is really just peer pressure, conformity, because the powers from above with the big money and the big ability to influence, they're forcing you to think a certain way. Okay, like you're forced to say, Hispanic organizations are trying to help Hispanic people. No, they're not. Most of them are all phony, and they're just trying to rip off the public and whatever funding that they can get, and they stink. Okay, and they're fake too. Like I said. They don't want smart Hispanic people around. They want their money, and they want everyone to just leave them alone while they collect all their money and laugh all the way to the bank. Okay. All right, continue with Thomas Shaz. Jung and Adler were an improvement on Freud, but they don't go far enough. The key is meaning. Meaning is what sets people free. And that's great. He's basically telling the truth here again. So what sort of empowers a person to endure all their sadness and disappointments in their life is that they live for some higher purpose, Like you can have a mother who she's working and she hates her job, but she's doing it because she loves her kids and they need her to do that. Okay, that's a typical scenario. And lots of people have said this. Dostoevsky has said this, and Schopenhauer said this many years ago. He said, the idea of living to have a happy life is impossible for most men. The best you can hope for is a heroic life. And if you feel you're doing something good, then that energizes you to do it. Okay, and Dostoevsky noticed too, and Viktor Frankl noticed the same thing. When a man has a good purpose, it strengthens him to endure whatever else he needs to endure. Okay, and Jung and Adler, yeah, they were a lot better than Freud, but there's still farther way to go. Okay, Jung was starting to see the importance of religion. Dostoevsky certainly saw it. And that's the other thing too. How come modern medicine never talks about religion? Because there's peer pressure not to. And so even though like Alcoholics Anonymous, the patients that convert to Christianity to replace the alcohol in their life get much, much better outcomes, much less likely to relapse. That's now frowned upon to say that, okay? But atheistic, drug-based medicine, it really doesn't work very well at all. It's kind of a big joke once you understand it. Okay, and so this is sort of comes from Dennis Burkitt's work, and what he basically said is if you have a population eating a plant-based diet with lots of fiber, you don't get that many sick people, okay? You'll still need emergency rooms for trauma. You'll need certain end-stage things. People get some rare disease going to kidney failure, the ability to put them on dialysis, do a kidney transplant, that's all great. But the main thing, every morning before a Western hospital, there's a river of fat, diabetic, hypertensives that just come in with all the Western diseases. And all the buildings look like these giant animal cages, and there's a statue of a turd in front. It's like the Thomas Wolfe quote. But that's modernism, okay? It's vulgar. It's kind of disgusting. Okay, I want to share with you the story of soteria. Soteria is a Greek word. It means deliverance. All right, and this doctor right here, Lauren Mosher, he used to be the head of the NIMH, National Institute of Mental Health. And way back, like in the 1960s and 70s, he had the idea that schizophrenic patients did better the less medication you gave them, okay? So he wanted to try it out in real life as experiment, and he had the resources at that time. So he set up these houses, just residential houses, and they were staffed by like these young people, like young psychologists or just young people that were interested in this type of work. And all they did was provide some supportive help to the schizophrenics, to make sure they got their food for the day, everything was going okay with them. And what they found was the vast majority of the schizophrenic patients were able to return to normal society. I think it was about 85% or even 90% in some places. It was repeated in several locations. They were able to return to work, obtain a job, maintain a marriage, much higher function than you'd expect. The ones that were put on drugs, very few of them were able to return to society. At the most, 15% in some places, in some other places, 5%. So then you would say, well, gosh, Lauren Mosher's done a great thing. He's helped all these schizophrenic patients. He has the best outcomes of anyone else. Should he not be celebrated? Give him a Nobel Prize? No, they fired him. Okay, they said, you are biased against drugs. Out, out, out. Get out of here. And he was fired. Okay, so that's the thing about medicine too that sucks. Okay, I hate that. What I'm getting at is, if you have a sports team, let's say you got basketball. Michael Jordan is a great player. Okay, he wins the MVP of the league award. So when an athlete is great, they're admired and they get paid more. And like I said too, I was a wrestler. When I saw a great athlete coming around, we would all watch this guy. Okay, here's this great wrestler from Iowa. What's he doing? How did he do it? All right, we admired it. We wanted to imitate them. We'd we'd go to a wrestling camp where we'd be taught by the best wrestlers. What I'm trying to say is it's not like that in medicine. The better you get in medicine, the more likely you are to be ostracized or even kicked out. Like I said, McDougall's a perfect example. He's the best doctor in the world. What happens to him? No one will send him a single patient. At times he worried, how he's going to pay his bills and feed his family. So that's what happened. Look at T. Colin Campbell, the great researcher who should be given a Nobel Prize and celebrated. Cornell, repeatedly tried to fire him. He just was protected by his tenure, okay? They hated the guy. And same thing, Caldwell Esselstyn, likewise for his business of preventing coronary artery disease. His hospital would not allow him to have an office to practice there. He had to take legal measures in order to be allowed to even have an office to see patients over there. They don't want it. Conventional medicine does not like this stuff because it knows it can't make money off it in comparison to what it's doing now. So that's what I'm trying to say is, the better a doctor gets, the more likely they are to be fired, blackballed, censored, harassed. It's disgusting how bad it is, okay? So people think, oh, the modern world is so much more advanced than these ancient societies or these religious societies. That is not true. I can assure you. Look at all these people. The population's fatter and sicker and worse off than it ever was before in my whole life. Medicine's not getting better. It's getting worse, okay? And I'm trying to protect you by teaching you all this stuff so you don't get chumped by it and abused by it, you or your families. Okay, so we went all through the outcomes on soteria. Here's another very good book. This lady, Grace Jackson, and she's a smart lady. She's a psychiatrist. And she says that psychiatric drugs basically cause dementia. Just like Bregan says. Bregan calls it a chemical lobotomy. She just calls it drug-induced dementia. And she systematically goes through all the studies, drug after drug, progressive destruction of cognitive function, and just a progressive cognitive deterioration. It's sad and pathetic. So Grace Jackson, good book. Okay, I read a whole bunch of books on psychiatry. I had considered going into psychiatry, but man, once I kind of went a little further down the road, I was like, no way. And that's when I thought imaging guided surgery would be the coolest thing, because then I could kind of combine a whole bunch of different areas of knowledge. All right, so we're going to get back, more into the theory of dementia. That was just a little sidetrack on what a disaster and a joke psychiatric drugs are. Okay, so here is a cell. This is glue for glutamate. Glutamate binds initially the AMPA receptors, and the AMPA receptors are sodium channels, and they allow sodium to come into the cell. So a sodium is an ion, a positively charged molecule. So the AMPA and the NMDA receptor are called ionotropic. They're ion-related receptors for glutamate. When glutamate binds NMDA receptor, this one lets calcium into the cell. Calcium can't come into the cell until the AMPA-related sodium has first depolarized the cell, meaning, increase the charge closer to zero, such that the magnesium will no longer be attracted to the previous negative charge that was in here, and the magnesium will pop out of the center of the channel. Now calcium can come in. Okay, so once you got all this calcium coming in, calcium will be increased in its amount in the cytoplasm, and that will now activate secondary processes. In addition, there's something called metabotropic glutamate receptors. We're not going to get into all that right now, but if anyone's interested, I give a previous lecture on this subject. I go into more details of, calcium, cytoplasmic calcium signaling. But for our purposes now, that really doesn't matter too much. Just know that increased calcium in the cytoplasm increases the activity of the neuron, increases its metabolic rate. And the catch is going to be there's lots of things causing increased calcium coming into the cytoplasm. And I really could have put voltage-gated calcium channels on here, but I sort of was only doing one thing at a time. But yeah, what happens to calcium is a giant big deal. All right, the next thing here is I just want you to understand what excitotoxicity is. Excitotoxicity means excitement causing a problem in the postsynaptic neuron. You overstimulate the postsynaptic neuron. So if you keep on having too much calcium come into this neuron right here, you're going to keep on releasing too much glutamate. And this can happen from psychological stress, from caffeine, from sleep deprivation. Other stimulants can lead to this indirectly or directly: amphetamines, cocaine, smoking cigarettes, all right? And you keep on sending glutamate across here. Also, glyphosate will activate this NMDA receptor. Beta amyloid protein can activate the NMDA receptor. So again, you depolarize, meaning more sodium comes into the cell initially when glutamate binds AMPA, for example, AMPA receptor, and then the charge becomes more positive, and this will start to depolarize the neuron. Now once this has become positively charged inside, or just closer to zero, the magnesium will pop out, and now calcium can flood into the cell. And if you have too much calcium up into that cell, you will then activate this destructive enzyme, calpain protease. And the perfect name again, cal for calcium activated, pain for painful consequences, and it will go around destroying important proteins. Like it'll destroy the NCX, that's the knockout exchanger that's used to pump calcium out of the cell. Once you destroy that, you can't pump calcium out of the cell so well. Calcium will accumulate in the cytoplasm, a vicious cycle will ensue, and the neuron will die from apoptosis. Okay, so anyways, here's calpain, and that's going to destroy the neuron. So you don't want calcium to go too high in that cell. That's a super important thing to get. Excessive calcium in a cell causes the cell to die from overstimulation. It's a very common cause of neuronal death, and it's a disaster. Okay. This is just sort of more of the same. I go into a little more detail, and I started also talking about the no pathway, but we don't need to get into that right now. But just so you know, these things are all synergistically working together to damage brain cells. Okay. And this term, excitotoxicity, was coined by John Olney back in the 1960s. He's the guy who figured out that MSG was toxic to the brain and that it should not be put into baby foods, okay? They put it in baby foods because it gets the baby addicted to the food. And then they buy more of it and the company makes more money. And there's tons of situations like that. You know, you have to choose the person over the money because there's always going to be more money for doing the wrong thing than for doing the right thing. Okay, so this is an example of, if you want to get the calcium out of the cell, you can pump it into here. So SERCA means sarcoplasm, endoplasmic reticulum, calcium ATPase for the name of this pump. Sarcoplasm is a term that just comes from muscle cells. In a regular neuron, it's just going to be endoplasmic reticulum. And this cell also requires ATP because you always need ATP energy to pump across against a gradient. And so you're pumping it into a concentrated storage reservoir of calcium in the endoplasmic reticulum to pump it over here. And then the PMCA, plasma membrane calcium ATPase, pumps calcium out of the cell. The knockout exchanger pumps calcium out of the cell. Okay, and this is just more things that calcium gets different types of cells to do depending on where they're located. Okay, and I know I'm going through a lot of this basic science, but the reason I'm doing it is if you get what I'm saying here, you'll be confident in understanding the major issue in the brain. And I can also tell you, most of the stuff you can't find it in neurology textbooks. Neurology textbooks, the Harvard textbook of neurology, 1,700 pages. There'll be one paragraph on excitotoxicity in the context of seizures. There'll be one paragraph on excitotoxicity in the concept of complications with stroke. And that's it. Okay, that should be like 100 pages and the most important thing for neurologists to know. And I know a lot of neurologists and they're very nice. I'm friends with them and I like them, okay? But I can tell you they don't know anything about nutrition, they don't know anything about epidemiology, and they know very little about toxicology because it's not taught. And then, like I said, too, most doctors don't learn much after they're done with their residencies and fellowships. They learn about the individual patients on the wards, how to get them through the system, but they don't learn much more about complex theoretical pathophysiology, nutrition, epidemiology, and toxicology because none of their board certifications requires any of this stuff. So there's no incentive to learn it, and no one expects them to do it. It's not in the standard of care anywhere. Okay, actually the point of this slide was just more of the same, showing you need ATP to get calcium out of the cell. The PMCA, this pump, it always takes energy to pump calcium out because you're always going against a gradient. Okay, so here it is in colored text. Because you always need energy, ATP, to pump calcium out, that means you need tons and tons of ATP to do this. And that means you need good mitochondria because that's where the ATP comes from. So if you don't have good mitochondrial function, you're screwed. Your neuron's not going to be able to pump out the calcium, and the cell's going to go into a vicious cycle of excitotoxicity. Remember, I just recently gave lectures that there's over 50 mitochondrial inhibitors. Not all of them are common. About 25 of them, half of those are common. All right, so there's a lot of them, and lots of people are routinely being compromised by these mitochondrial inhibitors. They're super common. So you don't want that. And the SERCA inhibitors are very common too. So this is how people get nickeled and dimed to death. All right, so here's just a picture, and I would joke this is like all roads lead to Rome, and there's just tons of processes that all lead to increased cytoplasmic calcium. Your neurons are ischemic. That'll lead to decreased ATP production, which will lead to decreased ability to pump out calcium, increased cytoplasmic calcium. You got a SERCA inhibitor, you can't pump calcium effectively into the endoplasmic reticulum, more cytoplasmic calcium. You got a mitochondrial inhibition, you can't make ATP, more cytoplasmic calcium. You got traumatic brain injury, neurons are destroyed, some of them, and then they release their cytoplasmic contents, including those neurotransmitter vesicles, out into the surrounding matrix, and that will then cause overstimulation of the adjacent neurons, and those can be damaged by the same process. Increased cytoplasmic calcium. Cell phone, Wi-Fi, EMF, open up voltage-gated calcium channels. More cytoplasmic calcium. Okay. The no pathway, I gave you separate lectures on that, but that also will lead to increased cytoplasmic calcium and cellular destruction. Okay, because you start making these peroxynitrites and they're very destructive. Okay, lack of sleep, psychological stress, and caffeine, coffee and tea, they'll all lead to increased cytoplasmic calcium because stress causes increased glutamate release from the presynaptic neuron. And caffeine elevates the same hormones as psychological stress. Cortisol and catecholamines. Catecholamines are epinephrine, norepinephrine. Same thing as adrenaline and noradrenaline. Okay, excitotoxins themselves, intrinsically. Aspartame, because aspartate's an excitotoxin, excitatory amino acid neurotransmitter. Monosodium glutamate, manufactured free glutamate. And there's tons more MFG, manufactured free glutamate. There's tons of it. We talked about this in a recent lecture about that book review I did of that lady's book, Fat, Stressed, and Sick. So all the companies do is they try to process the processed food as much as they possibly can as a source of glutamate and break it up into free glutamate, meaning separate individual amino acids, because that overstimulates our taste system. And our ancestors would see that as being rewarded for finding a good protein source, so we become addicted to that food, especially in the context of sugar and fat and salt as well. They have a synergistic effect. But I think you get the point. And glyphosate's also an excitotoxin, all right? Stimulants also have excitotoxin effect. Beta amyloid protein does as well. All of these things are increasing cytoplasmic calcium. So what's the point of all this? If you get multiple of these things happening simultaneously, you'll get too much cytoplasmic calcium, neuron's dead. All right, so this is how people are losing tons of their brain cells. Leaky gut is associated with leaky blood-brain barrier. Then you get more toxins into the brain, and that will cause inflammatory overstimulation of some of these neurons. Lack of diet, sodium and magnesium, you don't get them. You don't have your vasodilators. You can't run your ATPs. You've got a problem. And things that cause leaky brain, open blood-brain barrier, they will also cause leaky gut. So the two of them, and that's why you got to think about that in the context of stroke patients and traumatic brain injury. So here I'm just showing you even more. So this is what I'm saying is there's an extraordinary large number of things that lead to increased cytoplasmic calcium. And if you overdo it, that neuron gets overwhelmed. It says because the metabolic rate gets too high relative to the oxygen and glucose delivery, and it'll just die. And that's the Peter Rogers theory of neurovascular uncoupling. And you say, well, why? How do I claim this theory as my own? Because, yeah, tons of other people have gone before me and done research on it, but they're all kind of like specialized scientists working in a silo with just one narrow part of the field. I'm the person who was able to read everything about nutrition, epidemiology, neurophysiology, and just put all this stuff together and see it from all the different ways that it comes together. So it's really an expansion of calmodulin hypothesis, excitotoxicity hypothesis, and calcium hypothesis, if you will. Okay, and there's lots of things that factor into it. EMF factors into it. Nutrition factors into it. The basic toxins factor into it. The mitochondrial inhibitors factor into it. The SERCA inhibitors factor into it, okay? You can watch a lot of these experts in these fields, and you'll never, ever hear them talk about SERCA inhibitors, for example. You'll never hear them talk about EMF. You'll never hear them talk about nutrition. All right, so anyways, this is how it all works, and it actually ties in with the whole no pathway, which we're not going to get into much right now. I have separate lectures on that, and that a lot of that work too was done by Martin Pall, P-A-L-L. I think he's sort of did a fantastic job with that, popularizing that and teaching about that. All right, but you get the point. And there's a lot of weird little things, these toxic chemicals, volatile organic compounds, organic solvents, trichloro. These things are toxic. Benzene, formaldehyde. All of these things will activate reaction cascades that will lead to increased cytoplasmic calcium. What else? Beta amyloid, we talked about how that all works. Some of these pesticides. And what are good things you can do? You get your sunshine and you eat your greens, you get a systemic increase in nitric oxide. But that's not the same as having an uncoupled neuronal nitric oxide synthesis. This is a localized process, whereas this is a systemic process. Those are two different things. And that's why nitric oxide is a good thing when you talk about it in an artery or systemically opening up blood vessels. But it's a bad thing when you talk about it being overdone in an individual cell. So again, here's a diagram from my theory of dementia. And this totally empowers you, the individual, to just basically avoid all the bad stuff. Do the good stuff. Eat your low-fat, low-sodium, plant-based diet. Get your sleep. Get your sunshine. Maintain your social relationships. Have a purpose in your life. Have religion in your life. All of that makes you healthy. Everything that we've known for thousands of years makes people healthy, a lot of it. Okay, then avoid the things that are bad. If you overtreat hypertension, you drop your pressure too low. Why does the pressure get high in the first place? To get blood to the top of your brain. So be careful about taking too much meds. You drop your pressure and you've got cerebral hypoperfusion, then you're like the mouse, the Jack Delatory theory. At the same time, if your blood pressure is too high, that pulse pressure, like a jackhammer, keeps hitting at those arteries real hard, and it damages them, and they make collagen, fibrosis, to protect themselves from the high pressure. And that fibrotic thickening of the arterial walls leads to less oxygen delivered to the tissue, which over time contributes to apoptosis, because you're decreasing your oxygen delivery. And you also, just from aging, will have less ability to produce nitric oxide in your endothelial cells. So over time, you become more fragile. And that's why as you get older, you want to be more careful and thoughtful and strict on how you optimize all your dietary and health habits. High dietary sodium, you're going to vasoconstrict your arteries, less blood flow to the brain. High fat diet, you're going to drop 15 to 20% oxygen delivered to your brain tissues. Plus, you're going to push yourself into more diabetes, more hypertension, more atherosclerosis in your cerebral arteries. Okay, the problems of aging we spoke about, the problems of hypertension, atrial fibrillation. You lose that atrial filling, 25% drop in the blood you're sending up to your brain. Congestive heart failure, drop the pumping pressure of your heart, less blood to your brain. This is kind of Jack Delatory type stuff here, ways that you can decrease the glucose oxygen delivery. Aortic regurgitation, so your aortic valve is regurgitant, letting stuff fall back in. Aortic valve is stenotic, it's too narrow. You're going to get less blood supply to your brain. Atherosclerosis up in the intracranial arteries from chronic hypertension, especially, also from diabetes. Less blood supply to your brain neurons. Inhibition of SERCA, inhibition of mitochondria. You can't pump calcium out of the cell. Calcium's going to accumulate, predispose you to excitotoxicity. Okay? Low calcium, lack of vasodilatation, screwing up your plasma membrane gradients. Low magnesium, loss of vasodilator, loss of the ability to block the center of the NMDA channel for glutamate receptors, the calcium channel, more cytoplasmic calcium. Okay? Inability to hold those phosphates next to each other, the second and third phosphate and ATP. You're going to have less function of that potassium sodium ATPase pump in the plasma membrane of your neurons. You're going to have less ability to maintain your gradients, and you need those gradients to pump out calcium. So it's all connected. Excessive iron, you're going to have more oxidative stress, and you're going to need ATP to try to resolve that. Excessive amounts of the no pathway, we'll talk about that separately, but that contributes as well. And that's increased EMF can also activate that, inflammation also. And then what increases the metabolic rate? So first of all, you got a lack of oxygen and glucose delivery. And then second, you'll have an increase in metabolic rate when you're stressed out, sleep deprived, caffeinated, corticosteroid medications, smoking tobacco, amphetamines, or other stimulants, cocaine, attention deficit medicines. Glyphosate's a excitotoxin. Beta amyloid oligomer is an excitotoxin. Cysteine amino acid is an excitotoxin. So is aspartate, like in aspartame. The MFG is the big one. So the wider these things get so normally they're coupled. NeuroVascular coupling means the metabolic rate of the neuron is matched to the amount of oxygen and glucose delivery. As you stimulate the neuron, increases activity, you have to get that oxygen and glucose delivery up there, or this neuron's going to become dysfunctional and potentially die. But when you have all these things dropping the oxygen and glucose delivery while you're ramping up the metabolic rate of that neuron, eventually it just can't compensate, and it goes into program cell that says, screw it, I can't handle this. Just go ahead, recycle all my contents. Bye-bye. All right, and that happens to, many, many, many millions of neurons. And person's demented. They just progressively get a little slower, more like a cow, and then they, fall down, hit their head a couple times, and then they're toast. By the way, I see that all day long, every day. Oh yeah, what about sometimes people tell you, oh well, the free glutamate's not a big deal because the blood-brain barrier is intact and that'll protect people from the side effects. No, you can get the concentration of glutamate so high in the blood it overwhelms the blood-brain barrier even if it was intact. You've got areas around the third ventricle in the center of the brain that don't have a blood-brain barrier because they're chemosensors. They're called the CVO, circumventricular organs. An example would be in the brainstem of the vomiting center, area postrema, the pineal gland for making melatonin. These areas normally don't have a blood-brain barrier. Babies, really young children, don't have a good blood-brain barrier. Anybody who's got diabetes and hypertension has areas of injury in the brain where the blood-brain barrier is not working so well, and you can get access across there. Traumatic brain injury will open up the blood-brain barrier. Voltage, EMF from cell phones can open up the blood-brain barrier. You can get opening of the blood-brain barrier from excessive psychological stress, sleep depression. Those can do it. Excessive caffeine. All right, so it's not. There's a lot of ways you can increase blood-brain barrier permeability, and they're not good. Okay, and then there's lots of people who've contributed to all this work. Some of the excellent scientists, of course, John Olney in the 1960s got everything going with the concept of excitotoxicity. Russell Blaylock wrote a fantastic book in 1997 called Excitotoxins. And then lots of other great scientists, Mark Madsen, Dennis Choi, Danton O'Day. There's lots of other ones that have been studying excitotoxicity, some variant of it. Catherine Reed just wrote a great book on, especially on manufactured-free glutamate, the relationship of that to autism. Stephanie Seneff wrote a great book on glyphosate. Her book is called Toxic Legacy. Dean Murphy wrote a great book on F- in the water and what a mitochondrial toxin that is. Jane Hightower wrote about heavy metal toxicity, especially mercury. Martin Paul figured out all kinds of great stuff about the no pathway, nitric oxide peroxynitrite pathway, and including its relationship to EMF. And there's tons of other ones. Bruni Brody, in the process of trying to save her son's life, she learned quite a bit about SERCA inhibitors and found the scientists who could save her son's life, and she did. And just kind of like that really can inspire people, just like Catherine Reed was inspired to figure out glutamate to save her daughter's life, which she did. Her daughter had autism and she cured her. This lady, Bruni Brody, her son had something almost like a chronic fatigue syndrome, and by avoiding SERCA inhibitors, she was able to restore his health. The kid graduated from college with a degree in engineering. Okay, so anyways, I put it all together by being able to see all the different subfields and summarize it in a useful way. So I basically tell people, that's what you do. Avoid the things that lower oxygen and glucose delivery. Avoid the things that increase metabolic rate for no good reason, and you will protect your brain. Okay, and Jacques Delatour, of course, like Copernicus, had figured it all out. I think mine was kind of like Newton, establishing the basic laws of how you protect your brain, and I would categorize all these scientists. I made an earlier talk, like my previous talk before this one, I called Pioneers in Neuroscience, all these guys like Chptr that did fantastic work in some narrow part of the whole big picture, but awesome work. Okay, and this is just sort of a summary slide from one of my previous talks. I put it in here about the theory, and I jokingly called it boast. And I would call it boast because I'm saying, look, all I got to do is sit and think and read. Kind of like Watson and Crick figured out the structure of DNA, not by doing original research, but by just studying everything that was known and being able to put it all together. And I laugh because you could give any of the big universities $1 billion and they can't come up with anything because all they care about is finding a drug that they can win the lottery with to make a lot of money. And there's no money in actually just trying to understand things. There's no money in empowering the proles, okay? So this is just basically showing your brain function depends on oxygen and glucose delivery, and these are the things relevant to that. You benefit from the antioxidants from the plants to help counteract things like excessive free iron, for example. Avoid your stimulants because they unnecessarily raise your metabolic rate in your neurons, all the things that are involved in that. And the toxins are largely like stimulants or things that block oxygen and glucose delivery. Okay. So anyways, that's it. All these mitochondrial inhibitors will make things worse, but we're going to talk about that in the next chapter. So anyways, I hope that was helpful. And again, I said Jacques Delatour was like Copernicus. He got everybody's mind off all this BS about beta amyloid and phosphorylated tau, which just leads you into nowhere and you don't know what to do with that information. Okay, and then he gets you thinking about things that really matter, and he gives you a whole way to conceptualize everything. Jack Delatory theory. Okay, and then the next thing was all these scientists who'd done their part to figure out one part of the whole big system. And I use Kepler as an example of that. Kepler was a genius who figured out we don't need epicycles in astronomy. And then the next one was Newton, who I liken myself to, call me arrogant, but I think it's true, who saw the whole big picture and made some fundamental laws that anybody could go by. Don't lower your oxygen glucose delivery, and don't raise your metabolic rate. And there's tons of things that do that, so avoid them. Okay, and anyways, I hope that was helpful.